RSA algorithm. RSA algorithm is an asymmetric cryptography algorithm. Asymmetric actually means that it works on two different keys, public key and private key. As the name describes, that the public key is given to everyone and the private key is kept private. A client sends its public key to the server and requests same data. The server encrypts the data using the client's public key and sends the encrypted data. The client receives the data and decrypts it. Since this is asymmetric, nobody else except the browser can decrypt the data even if the third party has the public key of the browser. This is an example for encryption with public key and encryption with private key. First, the plain input text is inputted and encryption algorithm is applied. After the ciphertext is transmitted to the decryption algorithm, plain text output is been provided. Same with the encryption text with the private key. Each user generates a pair of keys to be generated for the encryption and decryption of messages. Each user places one of the two keys in public register or other accessible files. This is the public key. The companion key is kept private. Each user maintains a collection of data keys obtained from the other. If Bob wishes to send a confidential message to Alice and Bob, encrypt the message using the Alice public key. When Alice receives the messages, he decrypts it using a private key. No other recipient can decrypt the message because only Alice knows Alice's private key. The idea behind the RSA algorithm is based on the fact that it is difficult to factorize a large integer. The public key consists two numbers where one number is multiplication and two large prime numbers, and the private key is also derived from the same two prime numbers. So if somebody can factorize the large number, the private key is compromised. Therefore, encryption strength totally lies on the key size, and if we double the triple the key size, the strength of the encryption increases exponentially. RSA keys can be typically 1024 or 2048 bits long, but experts believe that 1024 bit keys could be broken in the near future, but till now it seems to be an infeasible task. This is an working of RSA algorithm. RSA algorithm uses the following procedures to generate public key and private key. Select two large prime number p and q. Multiply these number to find n is equals to p into q, where n is called as the modulus for encryption and decryption. Choose a number e less than such as n relatively prime to p minus 1 into q minus 1. This means that the p minus 1 into q minus 1 have no common factor except the choose e, such that 1 is less than e less than phi of n. E is the prime number to phi of n. GCD is given by this. If n is equals to p into q, then public q is e comma n. A plain text message m is encrypted using public key. To find the ciphertext from the plain text, following the formula is used to get the ciphertext t. Let us take some more example of a RSA algorithm. Step 1, p is equals to 7 and q is equals to 11. Step 2, n is equals to p into q, n is equal to 7 into 11, n is equal to 77. Step 3, choose a number less than n such that n is relatively prime to p minus 1 into q minus 1. It means that e and p minus 1 into q minus have no common factor except 1. Choose e such a way that e is prime to phi of n, GCD e comma d. Second, we calculate phi of n and we get phi of n is equals to 60 after applying the formula. Let us consider the relative prime number e of 60 as 7. Thus the public key is e comma n 7 comma 77. Step 4. A plain text message m is encrypted using public key e comma n. To find the ciphertext from plain text, from following the formula is used to get ciphertext c. To find the ciphertext from the plain text, following formula is used to get the ciphertext c. C is equals to me mod n 97 mod 77, c is equals to 37. Step 5. The private key is d comma n determined the private key. We use the following formula. After that, in this example, plain text is equals to 9 and the ciphertext is equals to 37. Thank you.